Hey, good morning, good afternoon, wherever you are in your day. The why here is just more, I'm going to use this word, spatial relationships. And really what that is, the way I think about it, is how big things are. But size. I've had to move a number of times in my life. I think I did the math a couple weeks ago with my wife. I think I moved 13 times before the age of 22. I've moved a number of times since then. So, not that I'm like a genius, but I feel like I have a pretty good awareness of how things fit spatially, like in a moving van. And I've seen activities where you sort that out and see if you can get all the furniture or boxes into that that kind of thing. Hold on one sec, I've got a visitor, so I'm going to pause the video. Alright, so spatial relationship size, sorry for the interruption here. We're just going to start with some identifications, some vocab. The height of this shape is just df. Okay, what is called the slant height is the height from the middle of one side to what's called the vertex. And you just think of it as like it is slanted. It's like if you got up on the top of a pyramid, slid down side, that's what you'd have, slant height. Vertex, I spoiled, vertex is the peak. The base is the opposite of the peak, the bottom. ABC in this case. It's a triangle. The lateral faces, there's three of them. So lateral is the side, right? So there's this lateral face right there, DBC. There is this lateral face right there, ADB. And then there's that back lateral face. Should be like that. Should ADC. All segments congruent to BC. Alright, so we've got some segments congruent to BC. BC is right here, and this is regular. So regular tells us that they're all the same. So BC is the same as AC and AB. Segments congruent to DC. So again, it's regular, so we got the vertex that's right in the middle. So DC is here. So all the same ones are DA and DB. Alright, so that covers that. Let's do some volume and lateral area and base area kind of stuff. So the volume for these pyramids and cones, the formula is volume is 1/3 base area times the height. So pretty much what we've been doing, except now we're going to multiply by 1/3. Okay, and that has to do with it's going to a singular point as opposed to going straight up, as we did with prisms and cylinders. So volume, it gives us the base area here in 8. So I'm just going to plug 1/3 of 141 times the height, which is 22. I just punch that in my machine. Okay, 141 times 22 divided by 3. Inches cubed. these two are down here are good because they're a little review of some of the stuff we struggled with on the last test and stuff we'll see on the final. Lateral area, total area, volume, still chipping away at it, still trying to get some growth here. So lateral area is the area of the sides. So the sides are all triangles and the triangles are all the same. And the area of a triangle is 1/2 base times height. Okay, and the base, we can look at any side that we want, but I'm going to put the 12 here because the 12 is going to match up with the 10. So 1/2, the base is 12, the height is 10. So that would be the area of one of the triangle, and then how many triangles are there on this pyramid? There's 1, 2, 3, and 4. There's 4 of them. So we just multiply. 12 times 10 times 4 times 1/2. You could do it by hand. 1/2 times 4 is 2 times 120, 4. So total area is lateral area plus base area. And the lateral area we just got, it's 240. And the base area is, oh, sorry, we got to add that. Base area is this square right there. And what do we know about base area of a square or area of a square? It's just the side squared. Length times width. 12 times 12. And when you do that all together, you get 384 inches squared. Okay, so what's the volume then? And we're going to use this formula up here. 1/3 base area times the height. 1/3 of the base area we just did there, it's 12 times 12, which is 144. And the height of this shape is 8. And when you do that on your calculator, you get 384 inches squared as well. Okay, so that's what that should look like. I'll give you a couple seconds to get caught up on that. And we will move forward. Alright, so lateral area of a cone is something I had to Google. There's no shame in that. I don't know how much we're going to do with it, but let me put it in. It is pi r 8 squared plus r squared. And it's just plug and chug. Pi, the radius is 12. Square root of the height is 16. The radius is 12. So I just plug that in the calculator. And when I did that, I got 753.98 centimeters squared. Total area is lateral area plus base area. I already have the lateral area. So I'm just going to take the lateral area here and add it to base area of a circle is pi r squared. So I'm going to add that to pi 12 squared. So I'm going to take this and add this, and this. And when I do that, I get 1206.3. Those are centimeters squared. Now the volume is what we dealt with over here, 1/3 base area times height. base area is pi r squared, which we did right here. And the height is 16. So we just multiply all that together. And we get 2412 centimeters cubed. Okay? So there you go. We'll practice and keep working on this and chipping away at this and some other stuff and moving forward with all this information and mathematics. Thank you for your attention. I am going to stop talking so we can move on with our day. Be well.